Why do we need to look at the sky? Partially because we are curious, and this is the basis of our whole progress, because we want to know about what we don't know yet, and we want to push the boundaries.
Time immemorial, man has gazed at the sky. It's been a wondrous thing to look at. I mean, when you see the Milky Way from a dark site, it's just phenomenal. And I think there's always been that urge to ask ourselves, well, what's going on out there? What else is there out there?
For tens of thousands of years, the state-of-the-art for looking at the sky was the naked eye. Then, a little over 400 years ago, Galileo built an optical telescope to amplify the light coming from the stars. Last century, we realised that looking at faint radio waves coming from the universe allowed us to explore even further. Soon after that, it was discovered that if you put two radio dishes together and looked at the same piece of sky, the whole became greater than the sum of its parts. As time goes on, we're looking deeper and deeper into space, and New Zealand is involved in a project that'll allow us to see 100 times further than we can now. It's the largest science project in history, and it'll add to our infrastructure and economy. It's called the SKA.
The Square Kilometre Array, or SKA, is an international radio telescope. It will consist of thousands of dishes, interconnected, looking at the sky at the same time. We will be able to see objects which we cannot see now. We will look deeper in the universe. If now we can study thousands of galaxies, we will be able to study millions of galaxies.
Already, New Zealand is hooked into a large network of radio dishes. It's called the Trans-Tasman Array. It begins near Perth and stretches across Australia and the Pacific, all the way to AUT's telescope in Warkworth near Auckland. This is the proposed skeleton of the SKA.
And New Zealand radio telescope, that relatively small 12-meter radio telescope, brings quite a huge advantage to the whole network of telescopes, because New Zealand increases the distance between radio telescopes by the factor of 2. We're increasing the resolution, the quality of the image.
As it stands, this is New Zealand's only radio telescope, built with a leap of faith and a desire to put our country in the running to co-host this mega science project.
Actually, it was AUT that took the initiative to go for the Square Kilometre Array in New Zealand. We presented our case to Australia a few years ago, and everyone liked it.
The biggest challenge with the SKA is that it will produce more data than anyone has dealt with before, ever.
The SKA is going to involve, to me, mind-boggling amounts of data. With a recent observation with the Trans-Tasman Array, we generated enough data to fill enough CDs to be stacked 42 stories high. So that's absolutely huge. Now that's just for the current Trans-Tasman. When we go to the SKA, that's going to be increased by 1 or even 2 orders of magnitude. So the sort of volumes of data we're dealing with are absolutely massive.
New Zealand and Australia jointly hosting the SKA would mean endless possibilities for both countries. The host of the SKA will be decided in 2012.
We have to look at it as one of probably the greatest projects scientifically that man's probably going to do for the next 100 years.
What are we going to discover? We will see. We hope there will be many serendipitous discoveries. Radio astronomy, for example, is responsible for the algorithms that MRI is based on, magnetic resonance imaging. Wi-Fi was invented by radio astronomer. And there are many, many other things were discovered by radio astronomers.
It's going to be huge for the economy, and it's going to be huge for the country.
Meanwhile, a new dish has been added to AUT's Warkworth Array, contributed by Telecom in November 2010. These will be the only 2 radio telescopes in New Zealand so far, but it's looking like they'll be part of the next big thing for science and for human discovery.